Assalamualaikum. Continue in MBM. Question 3. A plate 0.5 millimeter in distance from a fixed plate move at 0.25 meter per second and require a force per unit area of 2 Pascal to maintain the speed. Determine the viscosity of the substance between the plate. So this is the illustration of the problem. I suggest you to illustrate the problem in diagram. So here we have a fixed plate down here, and the fluid itself been illustrated by the blue line here. You have a thickness of 0.5 millimeter, so you have a moving plate that move upper side of the fixed plate with a velocity of 0.25 meter per second and have a force, a shear stress of 2 Pascal, which is force per unit area. Essentially it is a shear stress in fluid. So determine the viscosity. There is the formula for viscosity. You need to take note about it. The viscosity denote as this we call as nu equal to tau, denote as a shear stress, derivative of y with respect to u. So tau been given question, force per unit area. Y, it is shear stress. The value of shear stress, the unit, there will be Pascal. Whereas for force per unit area, essentially it is a translation for this formula, which is tau equal to force over by A. You will get Newton per meter square, or another unit would be Pascal. So force per unit area of 2 Pascal. So that's why the value of 2 Pascal is being illustrated for tau. It is just an origin. How did we define tau in this question? So tau, there will be 2, and the distance of y from the fixed position or fixed plate, there will be 0.5 millimeter. We need to convert in SI. Make sure that your calculation must be in the same unit, or to be safe in SI unit. If you are living in America or UK, they will using a different unit between standard. But in here, make sure that all distance must be in meter. So 0.005 divided by the velocity of the plate itself, which is 0.25 meter per second. Then you will get the dynamic viscosity. To be specific, there is 2 types of viscosity, kinematic or dynamic. So there is a dynamic viscosity. Question 4, I think I will cover in the next video. So thanks for watching. Have a nice day. Goodbye.